First of all, thank you for accepting this invitation. As a member of an NGO dedicated to people with rare disease, we really believe that it's a treasure to have you here with us. And I believe that your experience chasing your cure, not only your cure, but the cure for rare diseases, is something amazing. So welcome, Dr. David Fajgenbaum. Is that correct, Fajgen?
That's correct. It is, yes. Thank you.
Thank you. Thank you a lot. So, doctor, you were already a medical student when you discovered that you have Castleman disease. Rare disease patients know by heart how difficult it is to find a diagnosis. Could you please tell us how difficult it was to find your diagnosis and how it was your first lesson learned from the contact with a rare disease?
Sure. So for me, as you mentioned, I was a healthy third-year medical student. I was hoping to become an oncologist in memory of my mom. She had passed away a few years before from cancer. And I wanted to go into medicine when out of nowhere, I became critically ill. My liver, my kidneys, my bone marrow, they started to shut down. And so I gained fluid all over my body. I felt very flu-like. I had fevers and night sweats, and I just didn't feel well. And these symptoms continued and continued for a few weeks before I eventually just realized I needed to go to the emergency department and get checked out by a doctor. And so they ran blood work and they told me that my vital organs were shutting down. My liver, my kidneys, and my heart weren't working properly. So they hospitalized me and they began a series of scans and studies to try to figure out what was wrong with me. But in my case, it took about 11 weeks from the time that I was first hospitalized to actually get the diagnosis. And by the time they finally diagnosed me, I was so sick that my doctors had just told my family that I was unlikely to survive. And a priest came into my room and read my last rites to me, really prepared me for death. And thankfully, the diagnosis came in just in time. They were able to start me on treatment, and that saved my life. But unfortunately, I went on to have many, many more relapses. And so to your question around what lessons did I learn, I mean, I think the biggest lesson I learned is that in medicine, sometimes we have the feeling that we kind of know everything about all diseases, and that, you know, at least I was a doctor in training and I felt like, you know, we must have solutions to everything. But then all of a sudden, when I became a patient, I realized there are a lot of diseases where we don't know how to diagnose them rapidly. And unfortunately, we don't know how to treat a lot of these diseases. And so that's put me, as you mentioned, on a mission to try to advance research and treatment for rare diseases like Castleman's.
It's very rare to find someone with this double experience, to be a doctor and also a patient at your age. And how was the biggest lesson from this time of your life?
You know, I think the biggest lesson from having both of these perspectives, I think, and maybe it's not even from those perspectives, just that someone who's lived through what I've lived through, it's that, you know, oftentimes in life, we hope for things and we wish for things and we pray for things. We say, you know, I hope my loved one is diagnosed quickly, or I pray that there'll be a treatment for this awful disease. But what I've learned through my experiences as both a physician and also a patient and also a researcher is that we need to think about what we're hoping for and ask ourselves, what are we hoping for? Okay, if we're hoping for a treatment or a diagnosis, what can I do today to get us closer to that? So what sort of action can I take? And I talk about this a lot in a book I wrote called Chasing My Cure. It's actually out in Brazil. It's in Portuguese. I recently saw a post on social media. Someone had posted a picture of it.
It's great.
What I talk about a lot is this idea of turning hope into action. So what do you hope for? And then what action can you take? And so you're a wonderful example through your nonprofit. You're taking action. You know, you're faced with rare disease and challenges. You're taking action. And so that's the same thing that we're trying to do with Castleman disease. It's we hope for a treatment. So then we raise money, we raise awareness, we conduct research, we support doctors, we support patients. So we're getting closer to the thing that we're hoping for. So I think the number one lesson that I've learned is really, we should be hopeful, we should be prayerful, we should hope for things, but then we should act. We should say, okay, I'm going to hope for this thing, and now I'm going to take action. I'm going to go do something so that the thing I'm hoping for becomes a reality.
Today, an increasing number of patients and patient families are uniting in search of new forms of treatment for rare diseases. Do you believe this is something that make results that you can see that works, and how is the Castleman Disease Collaborative Network working to make this different in patients' life?
Oh, absolutely. So, we have an incredible community of Castleman disease patients and loved ones from Brazil to the United States to Europe, all over the world, that realize that none of us can do this on our own. So there's not a single one of us that can find a treatment or deal with the challenges of Castleman disease on our own. It's really critical we all work together. And so a few different ways that Castleman's patients contribute to the fight. The first is by contributing their medical data towards a study called the Accelerate Registry. So patients can actually go online and they can agree to let their medical data be used for research purposes. So we can learn from each case and we can put together all the pieces of the puzzle to better understand this disease. Also, patients can contribute blood samples towards research. So we can actually perform experiments on their samples, and patients can contribute funds so they can raise money for Castleman's research. They can raise awareness for Castleman's research. And then importantly, they can support one another going through really tough times. Unfortunately, I hear from families in Brazil too often. I hear from them struggling without a good doctor to take care of them, without a treatment that's available to them. So it's too often, because I wish no one needed the support, but there's certainly, and we are certainly doing our part to make sure that we help everyone to get the diagnosis, get the right doctor, and get the right treatment.
Once in an interview, you talked about the importance of the teamwork in developing new treatments. I don't think we ever witnessed so much collaboration like nowadays with COVID-19. What are the lessons we learned from these unusual years? Can we say that the pandemic changed in some way the perspectives of medicine?
Oh, absolutely. And I think you're totally right. I mean, number one, COVID has shown us that we can move much more quickly than we thought we could in the past. In the past, we thought it would take 5 to 10 years to develop a vaccine. It would take 10 to 15 years to develop a drug. It would take months and months and years even of research to figure out what we were doing to start. And COVID has proven that we can do all of this much more quickly. And so it's shown that the urgency that patients with diseases have, we've now seen doctors and researchers have the same urgency that we've always had. As patients, we've always wanted these things to happen quickly, but researchers and doctors and regulators have generally moved with a lot less urgency than we have. And so I think this is a good example where we're all moving forward with a similar urgency to make as much progress as quickly as possible. So one is urgency. Two is sharing of information. I've seen an incredible amount of data. If my lab does something or another lab does a study, we put that data available online right away. We want to make sure that anyone can get access to it. They can learn from it. We're all working towards a common goal, whereas typically there isn't nearly as much sharing of data. We like to keep our data to ourselves and work with it on our own and not really share it. In addition to data sharing, there's also a lot of interest in working together with one another. Even if it's in the past where maybe we'd say, you're going to do that, I'm going to do this. Now it's, if you're doing that, I'm kind of interested in it. Let's figure out ways to work together. And lastly, the fourth observation that I've made is the real interest in what's called drug repurposing. So the idea of taking a drug, the initial purpose may be Castleman disease, and now you try it for COVID, or a drug where the initial purpose may have been cancer, and now you're trying it for an autoimmune disease. But it's this idea that drugs, we oftentimes think about a drug in terms of what it was initially developed for. That drug was made for the flu, or that drug was made for Castleman's. But what's very clear, and what's always been clear, is that drugs can work in many diseases. You just have to figure out all the other diseases that they may be helpful in. And so COVID has shown us there have actually been over 500 drugs that have already been tried as treatments for COVID. And a number of those drugs, about 5 of them are clearly effective, and another 5 to 10 are likely effective. And so that's sort of, proof that thousands of lives have been saved from COVID, based on drugs that were developed for totally different diseases 50 years ago, hopefully proves to our community that we need to do a better job of utilizing drugs for all the diseases that they might be helpful in.
Gene therapy is for many rare disease patients the only possibility ahead. How do you see the advances made in this area? Are we facing a kind of a revolution in terms of treatment?
I believe so. And I think the reason for that is a few. The first is that for many years, we were very hopeful that gene therapy would be the cure for every rare disease and that it would happen, snap of our fingers. What we found is that it is a cure for a number of diseases. And actually, there are two now gene therapies that are on the market that are saving lives, restoring sight in individuals who are blind. So we've shown that it can happen. We can do it. But what we've also learned is that there are a lot of hurdles and roadblocks along the way. So one particular gene therapy using one particular vector may work for one disease, but may not work for another disease. And so we're learning that it's complicated. It's not going to be a snap of the fingers and every disease is going to have a gene therapy. But the good news is that there are other nucleic acid modalities like RNA, which was utilized for the vaccine that so many people have received, that can absolutely be used for therapeutic purposes. So the better we are at manipulating nucleic acids, whether it's gene therapies where you insert DNA into a virus and insert the virus into the body, or you inject RNA into your shoulder like we do with the vaccine, as we continue to improve our ability to utilize nucleic acids, I think that we're going to get better and better. There's things called antisense oligonucleotides that act similar to RNA and similar to gene therapies, but I think we need some more tools in our toolbox. But as we're getting more and more tools, I'm getting more and more optimistic that these drugs are going to be helpful for rare diseases.
We had a lot ahead.
We do. We have a lot to be hopeful for.
Yes. 2 years ago, Casa Hunter promoted a meeting with Dr. James Wilson, professor and director of the Pan Gene Therapy Program and the Pan Orphan Disease Center. For some doctors, much of the content of this event was a surprise, but almost everything changed in 2 years. We have, with testimony, this huge acceleration. What does gene therapy bring us ahead? What patients can wait for?
Yeah, I think that the exciting opportunities in gene therapy, in my opinion, are that we're going to start understanding when platform approaches can be used, meaning that one particular vector could be helpful for 5 different diseases if we can just load in different genes into that vector. And so it's this idea of, rather than needing every single gene therapy to need to go down the whole development process for every individual disease, if we can start getting platforms where we say this particular vector can be loaded with these 5 genes and can be useful in these 5 different diseases, I think that's going to be important, because there are a lot of rare diseases and it's going to take a long time. If every single disease is going to take 5 to 10 to 20 years to get one gene therapy, it's going to be too long. And so I'm optimistic about the idea of platform technologies. Antisense oligonucleotides also present a potential benefit here, where if you can predict that particular antisense oligonucleotides are going to be likely to be helpful and safe, then you can potentially get approval from a regulatory body for the use of that platform or that set of antisense oligonucleotides, and they can be helpful for multiple diseases. And I think that's the key, is that it can't be one gene therapy, one disease, 20 years. I think we have to figure out ways to utilize similar gene therapies across similar diseases.
Some of Casa Hunter patients are currently participating in a gene therapy research. This advance is a fact, a reality. Costs, however, remain a challenge to any deployment model. How are we going to make such a personalized and extremely expensive medicine feasible?
It is. It's really hard. And I don't have any good solutions for it. I mean, I think that it's the kind of thing where the more and more we produce gene therapies, the more vectors that we develop, the cheaper the cost should become. You know, I think that as you get to the 10th and the 20th gene therapy, the cost should start to come down, and actually producing it and also in developing it and doing the trials. You know, as more and more successful drugs make it to the finish line, in theory, that's going to mean that the cost per drug and the time to get that approval is going to go down. And so hopefully that'll mean the cost to the consumer, to the government, is going to go down as well. But unfortunately, I don't have any really good ideas.
Yes. This is the big challenge, I believe. Concerning Castleman disease, what are the perspectives for those who received the diagnosis of the pathology today?
So if you're diagnosed with Castleman disease, the first question needs to be, do I have unicentric Castleman disease, or do I have idiopathic multicentric or HHV8 associated multicentric? Because that's really going to really affect what treatments you receive and what your outlook looks like. If you have unicentric Castleman disease, we're going to do the best we can to surgically remove that lymph node, and you can go back to your pre-Castleman disease life. You can be cured, and for the most part, feel quite confident it will not come back. But if you have multicentric Castleman disease and it's caused by a virus, HHV8, you're going to receive a drug called rituximab. And the good news is that you have an over 90% likelihood that that drug's going to work for you, and you're going to do quite well on it. And so you might have a relapse, but you'll probably get retreated with rituximab and you'll do well. Now, if you have what's called idiopathic multicentric Castleman disease, which is the subtype of Castleman's that I have, which, as you mentioned earlier on, I was diagnosed with while I was in medical school. If you have that subtype, and about 1/3 to 1/2 of us will respond to a drug called cetuximab that's highly effective for a portion of patients. If it works for you, you are very likely to have a long-term benefit from the drug. But if the drug doesn't work for you early on, it's unlikely to work for you long-term. And so you're going to need another treatment. And so if you fall into the category where you've got IMCD and you get better with cetuximab, you can have a really good positive outlook for the future. But if you have IMCD and you're like me and you don't benefit from cetuximab, we are still searching for the right drugs for you. And so research is really going to be the key to us finding the right drugs for those patients. And therefore, our outlook is a little bit less optimistic than people who either have UCD or get treated with cetuximab.
I would like to end this meeting thanking you and asking you, what message would you like to leave for the Brazilian with rare diseases, and especially for patients with the Castleman disease?
Sure. I think I'll maybe close with a lesson that I learned from my mom many years ago. Many people encourage us during really tough times, like when we're diagnosed with a disease like Castleman's or another rare disease. They encourage us to look for silver linings, to say, okay, I was diagnosed with Castleman disease, but at least that means I get to spend more time with my wife, or that means I get to have the opportunity to focus on the important things in life. We look for silver linings. But what my mom always encouraged me to do was not just to look for silver linings, but to look to create silver linings, meaning that, okay, I have Castleman disease. It's really tough, but what can I do today to turn this into a positive? Can I give a blood sample to research? Can I talk to another Castleman's patient and make them feel better about themselves? Can I donate money to Castleman's research to enable a cure for someone 50 years from now that's going to benefit because I did something? And so I think that I'll encourage everyone watching to, in the midst of tough times, we need to take care of ourselves and we need to appreciate the challenges. But I think we also need to think about what can we do today to make a silver lining out of something that's really, really, an objectively difficult experience. And, if that sort of a message resonates with you, then I hope that you'll follow our work. You can go to cdcn.org for the Castleman Disease Collaborative Network, or you can go to chasingmycure.com. You can learn about the work that we're doing. You can follow us on social media. You can check out Chasing My Cure. I don't know the right way to pronounce it in Portuguese, but I did see the book cover recently and it looks really nice. But truly, it's about, I believe it's about recognizing the challenges, but then asking ourselves, what can we do today to turn this really tough situation into a positive?
So before we end this interview, I would like to recommend the book of Dr. David Fajgenbaum, Chasing My Cure, already translated to Portuguese. Do not lose this opportunity. Thank you a lot for your presence, doctor, and we wish you a long and a healthful life.
Oh, thank you so much. This means so much to me. I'm glad we had the opportunity to chat. And years ago, when I was so sick, I never thought that I would be alive and healthy today and have the opportunity to speak with you and to share my story through a book. And so the idea that these lessons can be shared through this interview in other ways means a lot to me.
Thank you.
Thanks so much.